To Algebra 2, Lesson 3-3, Example 3. In this lesson, in this example, we will use polynomial identities to factor and simplify. How can you use polynomial identities to factor polynomials and simplify numerical expressions? So first of all, we have to identify our forms, and so we have to compare them with the identities we've learned, and then we have to use them when we identify what's A and what's B, and then we can just plug it in and simplify. So let's look at several examples here. So look at part A. 9m to the 4th power minus 25n to the 6th power. They're both perfect squares. So you're going to rewrite them as squares. Because the powers are not the same, you should convert them into the squares, right? We have learned the difference of squares, difference of cubes, square of a sum of cubes. So we need to rewrite them in squares or cubes. So those are the things that you're looking for. Can we rewrite them as squares or cubes? For this problem, we can rewrite them as squares. So 9m to the 4th power could be rewritten as 3m squared to the 2nd power, right? So yeah, so 3 squared is 9, m squared to the square is to the 4th. And then the same way, 25n to the 6th power is also a perfect square. So 5n to the 3rd power to the and all of that squared would be equal to each other. And so now we have a and b. We can use the difference of squares identity, which is a squared minus b squared equals ab times a minus b to solve them. So using a and b, using a 3 as 3m squared and b as 5n cubed, you can just rewrite it as 3m squared plus 5n to the cube power times 3m squared minus 5n cubed. Okay, so then you can factor them out like that. So you factored it out already. So that's good. So it is a lot more helpful when you're actually factoring them out. So instead of multiplying them out. So yeah, because multiplying may be easier, but factoring may be a little bit more challenging. So you need to be able to identify the polynomial identities, and if you can, use them so that you can factor it out easily. Let's look at part B. X cubed minus 216. They are also perfect cubes. So x cubed is already a cube, right? 216 could be rewritten as 6 cubed. 6 times 6 is 36. 36 times 6 is 216. So using the difference of cubes identity, this is already in the form a cubed minus b cubed, right? So you can use a and b. This could be a, that could be b, and rewrite it like as factors like this. So x cubed minus b, 6 cubed times x cubed squared plus x cubed times 6 cubed plus 6 cubed, and then you can say that you factored it out. Ready? So there you go. The last one. If we are just using constants, it's really a good practice. If you look at 11 cubed plus 5 cubed, we already know they're cubes, right? So then 11 could be a, 5 could be b, and just plug a and b here. So 11 plus 5 times 11 squared minus 11 times 5 plus 5 squared. And then you factored it out, but for constants, you already know how to calculate them. So calculate and then you multiply, you'll be able to find the value easily. All right, let's look at try number 3. Use polynomial identities to factor each polynomial. So look at your polynomial identities and compare them to recognize which polynomial identity we're looking at. So in this problem, you know they're all going to be used by polynomial identity. So look and see if you can find them yourself. Pause the video and come back when you're ready for answers. Okay, are you ready? So let's look at part A. What do you see? Well, there is a subtraction. So the subtraction that we see could be related to the difference of squares or difference of cubes. Could we write them as difference of squares or difference of cubes? Yeah, so how would we write them? What's A? What could be A and what could be B? We can write them as squares. Cubes don't really work here because of the powers, right? So we can say that A is m to the 4th power, because if we square that as a square, that would be m to the 8th power. So a squared minus b squared is the form that we are looking at. And then so that's 4. B could be 3. So root the entire term. 3n to the 5th power, right? And then you just use the form of difference of squares to plug it in. M to the 4th power plus 3n to the 5th power, so a plus b times a minus b, m to the 4th power minus b 3n to the 5th power would be a factored form. And then that's it. You're done. Look at part B. What do you see? This is also a difference, but you see a difference of squares, right? Difference of cubes instead of difference of squares. So you can rewrite this. You can identify A as if you cube root all of them, you'll get 3x cubed, and B could be what? What is root 343? Could be 7y squared. And so that's a cubed minus b cubed. So then you can rewrite this as a minus b times the trinomial a squared plus ab. So that's 21 x cubed y squared plus b squared. So that's 49 y to the 4th power. Okay, so that should be the factored form for part B. And lastly, part C. You already see cubes, right? So what could this be? It's not a difference of cubes because it's added. It's a sum of cubes. So then using A and B, A is 12, B is 2, right? So A is 12, B is 2, and then you can rewrite it as a plus b times a squared minus ab plus b squared. So if you calculate all of them, you should be able to get 1,736. So simplify them using the difference, using the sum of cubes. All right, so that was try number 3 and example 3. We'll continue with example 4 in the next video.